Welcome back to our physics class. In my previous class, we studied the graphical representation of motion. Means how we can represent motion by graph and what are the benefits of it. Today, we will study equations of motion. Now, before we study these equations of motion, three important things. Number one, these equations of motion are not big black booth which will jump off from your copy or book or they will eat you. Number two, no need to rectify all those things because I have seen those who rectify these equations, they are useless. Number three, they are the simple relations. They are the relations which relate initial velocity, final velocity, uniform acceleration, time, distance, displacement. They are just relations. And remember my first class what I said? Physics is simple. Why? And numericals are very simple. Why? Because if there are three things, they will give you two and they will tell you to find out third. If there are four things, they will give you three and then they will tell you find out the fourth one. So simple. Anyway, so these equations of motions are basically the relations which relate the physical quantities which we have studied so far. That we will discuss later on. How these equations came, from where they came. One fine morning, great Mr. Newton got up and wrote something and that became an equation or that became a formula. Was it like that? Or is it like that? Or will it be like that? That one fine morning you get up and write and say this is the big physics or research in physics? No, not possible. Any formula or any theory which we develop in physics or in any science say has to have a basic support or a background support or a theoretical support. In plain words, you can't say I made a fifth story. Where are first, second, third, fourth? So the knowledge is like that. First story, second, third, fourth, fifth, sixth, 10, blah, blah, blah. That's how knowledge develops. Anyway, we are back to our equations of motion. Remember when we were describing motion and we were describing it graphically? From this graph we concluded something. So when people studied that graph in detail and analyzed the graph, catch the word, when they analyzed the graph, came out with some beautiful relations. And these relations are famously known as equations of motion, and there are three. What are they? Just see for a glance. First equation is V equals U plus AT. Second equation is S equals UT plus half AT square. And third equation is V square minus U square equals 2AS. Now what are these A, B, C, D, E, F, G, H? Are they simple alphabets? No. Back. What are these? U, A, T, S. These are the standard symbols representing physical quantities. U, remember? U represents what? U represents initial velocity. Good. Those who got the answer, clap. V represents final velocity. A here represents uniform acceleration. T represents time and S represents the distance. So, when I say first equation, V equals to U plus AT, what is it doing? The first equation is relating initial velocity, final velocity, acceleration and time. When I say S equals to UT plus half AT square, what does it mean? It relates distance travelled with initial velocity or speed U at time t with uniform acceleration A. Now, similarly the third one, V square minus U square is equal to 2A. Now let's see how we derive them. Because in exam they will ask, using graphical methods, derive first equation of motion. Now, 3-mark question. Now, if it is mentioned using graphical method, derive first equation of motion, make sure you are using only graphical method to derive that. You can derive this equation of motion by so many different ways. But here in 9th standard, you have to derive it using only graphical method. And those who are little thinking beyond, try to derive it in different other methods if you know. Anyway, how do we derive? Once they say derive it graphically, our job is to draw a proper graph. When we draw a proper graph, another important thing is that you have to describe the graph. Your teacher does not know what you have taken what. Because the beauty of science is that you are free to choose your notations and all that, provided you make other people understand. If you write U, a layman will not understand. Or those who have not studied physics, they will not understand. U means initial velocity. So, once you draw a graph, properly label it and then describe the graph. Now see how I have done there. Here you got a velocity time graph, velocity on y-axis, time on x-axis. Look at the graph at the point A when the time t1 is 0 you got initial velocity u. As the time passes, the velocity represented at b, that is the final velocity v. Got it? Now, in the picture or in the graph, OA shows what? Initial velocity. OB shows what? Final velocity. Now look, little add subtract. How much will be BC? It will be V minus U. Agreed? And what will be AO? It is T final minus T initial, TF minus TI, that is equal to total time. Now, remember, when we were describing motion, what we said? Slope of velocity time graph represents, anyone can think, represents acceleration. So here A will be equal to the slope of the graph AB. That is taken as BC upon AC, and put all those values. BC will be V minus U. AC will be T2 or TF minus TI, T final minus T initial. AC will be equal to, find out, and Y also. So AC will be equal to T. Just simple cross multiply and transposing here and there. What you get? V equals U plus AT. Simple. Come back. So you got V equals to U plus AT, one formula, one equation of motion. Great thing. Is it? No. It is a simple relation which shows the relation between V, U, A and T. That's all. Now, second one. What is the second equation? Second equation is S equals to UT plus half AT square. Look at my presentation. That's here again the graph. Graph is properly labeled. OA represents initial velocity. AB represents, think of, uniform acceleration. Now remember what we learned. Area enclosed under velocity time graph gives the distance. So the area enclosed below that velocity time graph is what? See, with the red color there is a triangle, and with the blue color there is a rectangle. So the area enclosed on velocity time graph showing uniform acceleration is equal to the distance. So the distance will be area of rectangle plus area of triangle. Okay? Area of rectangle, you know how to find out? Length, time, breadth. And area of triangle also you know how to make. Half times base times altitude. So, what you have? Area which represents the distance S is equal to UT plus half into t into v minus u. Now, that is a catch. Now what to do v minus u? We don't want to use this v minus u. So simple transposition what they have done. From equation 1, v minus u will give you at. So put the value there. And what you get? S equals ut plus half at square. Right? That is our second equation of motion. Come. Now, we have learned two equations of motion. Third one. Third one is nothing but just simple, what do you call, some intelligent way of looking at things. You know, that is beauty of science or beauty of physics. The same velocity time graph, the same area, but now in the previous example 2, what we got? Area of triangle plus area of rectangle, or area of rectangle plus area of triangle. Here, look at the graph. Is it not the same graph? Same graph. But here, red color, what we are finding? Instead of dividing it into two geometrical figures, we have taken one single geometrical figure. And what is that geometrical figure? Those who can guess it, well and good. What is it? Of course, it is a trapezium. So, saying the distance covered in a velocity time graph is represented by the area. Here, it is area of trapezium. How do you write area of trapezium? Remember your 8th standard mathematics? 8th standard mathematics. Half multiplied by sum of parallel sides multiplied by the altitude. Now, look at that. Half sum of parallel sides. Here parallel side will be OA plus the another one. Right? Why they are parallel? Think. And if you cannot get the answer, put your question in that message box. I will tell you why they are parallel. Anyway, the sum of parallel sides, V plus U multiplied by distance. Multiplied by the altitude. And what this altitude represents? Time. T. Now, I don't want T in my business. So what we do? Again, simple replacement from equation 1. Do little bit of transposing here and there. And what you get? T equals V minus U upon A. So when you do little bit of working out, you multiply. S will be equal to V square minus U square upon 2A. Why? V square minus U square. Remember your algebra formula. A plus B multiplied by A minus B gives you A square minus B square. Got it? Yes. So, another equation of motion we got. V square minus U square equals 2AS. That's good. So, come back. Now we have 3 beautiful equations. How they came, you know now. What you have to do now? As I told in the beginning, need not to rectify it. Because if I give you a machine gun and I tell you to fire, you will not fire, you will break your hand and leg. So these formulae are the guns, the weapons which you need to fire. And you cannot fire a weapon if you have not practiced it, how to fire or when to fire. So the most important thing is that you will do a numerical, or whenever you do a numerical, write the formula. And suppose you have done 10 numericals. So you have written the formula 10 times. And you know where to use that formula. Simple. So no need to ratify. If you do 10, 15, 20 questions, all formula by heart, all in your head, I think my today's class, good enough. Now, thank you very much for those who asked their questions in my box. One fellow asked about how you survive the area represented by velocity time graph shows distance. Now is it clear? I think one fellow I answered in his inbox reply. For a body moving with uniform velocity, what will be the graph? A line parallel to time axis. Take the time t. Just see, you will get a rectangle. What is the formula for distance? Speed into time. Look at that graph. Speed will be v, time will be t. So area of rectangle. Simple. Anyway, thank you very much students for asking, very good questions. Thank you very much also for appreciating my class. Hope now further lockdown. So you will prepare your class properly. You will do your homework properly. You will send your homework. Once again, thank you to all those children who write my homework back. Thank you for asking some brilliant questions. Thank you for encouraging me by writing good comments. Stay home. Stay fit. Stay healthy. God bless you. All the best.